Centrifugal force, you ask? No? Well, I'm still going to teach you because
I don't care.
have you ever been on these rides? Has your dad ever tried to kill you in a playful manner? Have you ever been in a centrifuge? Have you ever been a daredevil? Or ever thrown out in orbit? If yes, then you're ready for the video I'm going to explain. If you look out of that door, you will find this whole compartment is rotating and all these kids are pushed against the wall. But why this happens? Is this some sort of magic? Or they are in an anti-gravity UFO? Well, let's find out. Take this girl for instance. She's also wondering why she is stuck to the wall. Since she has no clue about it, so she says a fictitious force or pseudo force is pushing her. The pseudo force in a circular motion is known as centrifugal force. But why she is not sliding down due to the gravity? Because frictional force is countering the gravity. Whatever we are observing is taking place in a non-inertial reference frame, which means we, the observer, is also doing the same motion. Now this guy is giving the best analogy of the ride you saw in the previous video. He's providing a circular motion to his setup due to which it behaves same as the ride. Labeling will help you find the similarities between the elements of both the videos. This observation takes place in an inertial reference frame, which means we, the observer, is at rest. If we look at this motion from the top, we will see the object is doing a circular motion has a velocity. The direction of this velocity is tangential to the circular path. If somehow the object deattaches from the string, it will fly away in a straight line in the direction of its velocity. Since the object is always trying to travel in a straight line, the string tugs it toward the center, due to which a tensile force is developed in the string. The direction of this force is away from the object seeking the center. The center seeking force is called the centripetal force. But we remember our setup was a bit different. It had a platform, but that doesn't change the situation. Instead of tension, the platform is pushing the object to travel in the curved path. Similarly, in the ride, the wall was pushing, but floor and roof of the ride was in tension. In any gravitationally attractive system, gravity is the centripetal force. So clearly, the centrifugal force exists only in the non-inertial reference frame. What if instead of two objects encircle a common point? Well, don't worry, we are not going to talk about the black hole. We are just gonna kiss. No, not this one. KISS stands for keep it simple, stupid. Now simply imagine you and your friend are passing the ball in this apparatus. No matter how good your aim is, you will always fail to pass the ball. Well, why? Let's observe from the guy's point of view. He observes the ball coming away from his partner. Well, if we jump out of his frame to the ground, we will see there is nothing strange. The ball keeps moving in a straight line. The curved path is just an illusion due to his own circular motion. So this illusion which makes the object appear to move in a curved path instead of straight line during a circular motion is called Coriolis effect. The end? Nah. What if instead of two objects we use a liquid? When a liquid undergoes a circular motion, a vortex is formed. P subscript T and P subscript B are the pressures at the top and the bottom respectively. Since pressure is directly proportional to the depth, hence P sub B is greater than P sub T. So the pressure gradually increases with the depth, due to which the vortex gets compressed at the bottom and hence the radius of the vortex decreases and it shrinks with the depth. Since the velocity is directly proportional to the radius, it also decreases with the depth. Let's see what happens to the vortex under zero gravity. In zero gravity, no force is developed in the water and therefore no force is exerted on the vortex. So there is nothing to stop the water from flying away to the wall. Therefore, pressure of the water is the centripetal force in the vortex. If you find this video informative, share it with your friends.
Thank you!